the curve, this should be 0. So it's a curve whose components satisfying this second order differential equation. Okay? Any question about that? Any question?
So please explain this last result, the acceleration of gamma, this red thing. What is this happening here?
In this red?
Yes. X double dot k.
Yeah. Here I define derivative y along gamma. And we said that its kth component is yk dot plus this guy. Okay? Now all what I'm doing is just replacing y with gamma dot, because I need the derivative, not of any y, the derivative of gamma dot. So from this expression, I'm simply replacing each y by my gamma dot, which is the xk dot. So xk dot dot is double dot, and here yj is x dot j. That's it. This is what I did. Just applying the definition of the nabla. Here is the general definition of the nabla. So here is the general definition of the nabla. I'm doing nabla, gamma dot, and this guy is gamma dot. So the gamma dot is x1 dot up to xn dot. So this is xj dot. This is xi dot. This is xj dot. This guy is xk dot. Okay? So here is the geodesic. The definition of geodesic is simply a curve with zero acceleration. What is the acceleration? Here is your acceleration. Okay? And it's all just boils down to the wave differentiation. It's pure geometry, right? Pure geometry. Tell me how you're going to differentiate along this curvy surface. How are you going to do differentiation on that curvy surface? This is pure geometry and calculus together, right? This is why it's called differential geometry. Based on that, I give you how the straight line will look like. The straight line will be a curve whose components satisfying the second order differential equation. Let's look at the sphere as an example. Let's look at the sphere. Maybe you can continue here. Do you have any questions so far? Any questions? Yes, check this.
Xk double dot, is that a factor?
The little x's are the coordinates.
Yeah.
So the little x's may be phi and theta. So xk double dot, k runs from 1 to n. So x1 double dot, this is maybe theta double dot. x2 double dot is phi double dot, and so on and so on. Let's have an example, and hopefully things will be clear. So an S2 with Q's that are theta and phi. Okay? Theta and phi. I want to know what is a straight line on a sphere. Straight line on a sphere. Obviously, it's not just straight line in the three-dimensional space. Why? Because this is not actually belonging to the sphere. So if I come at this point and I want to go to that point, and you draw a straight line in the three-dimensional space, this is simply takes you out of the sphere, right? So this is the Earth, for example, and you want to travel by car along the surface of the Earth, surface of the sphere. You will not fly outside. So along the surface, I want to go from here to there. Along a straight line, I cannot do this, right? It's just inside the sphere. You have to travel along the sphere. We'll talk about this in detail next time. But these differential equations simply gives you how your phi and theta will change with time to travel along the straight line. Okay? The straight line along the sphere will not be straight line in the ambient space. What do we mean by straight line? Here is your definition of a straight line. It's a curve with zero acceleration. So let's apply this definition. So theta here is my first coordinate x1 or q1. This guy is x2 or q2. And my gammas, which are up to this point, they are just magically given to us. Gamma theta is what? is 0, 0, negative tan phi, negative tan phi. And gamma phi is what? Is sine phi, cosine phi, 0, 0, 0. So the first equation of the first coordinate, q1 is theta. Here is the first equation. Please apply this guy. Simply.
Theta double dot.
So theta double dot plus. How do we apply this guy? This is easy. We do this. We do a row times a matrix times a vector. Okay? What are the rows? It's the x double, it's the x dots. So
Theta dot.
theta dot phi dot. And the same here. Theta dot phi dot. Okay? Please just bear with me and see how we construct things, and you will have time to write. What is this matrix? It's the gamma corresponding to the first guy.
0 minus.
So this is gamma theta. So this was 0, negative tan phi, and 0. So this is theta double dot. Do this matrix multiplication on your own pace, that's fine. A row times a matrix times a column. You will get negative 2 tan phi, theta dot phi dot equals 0. This is the first equation. Any question about how to construct the first equation? Please. Any question how to construct?
How did we constructed these two matrices?
No, I'll talk about this later.
Okay.
So far you're given, gammas you're given how to differentiate on your manifold. I'm saying that these gammas dictate everything. Okay, the next set, second equation. Q2 is your phi, or x2 is your phi. I'm sorry that I'm confusing you between the little q's and the little x's. I asked you last time, it seemed that there was no confusion. So, the double dot of your coordinate, which is phi double dot plus, it's the exact same structure. Theta dot phi dot as a row times the matrix times theta dot phi dot as a column, and this matrix now is gamma of the second coordinate, gamma phi, which is sine phi cosine phi 0, 0, 0. This gives you phi double dot as is plus. You can see here it's theta double dot times this guy times theta double dot again. And take some time to write. See, I'm giving you some time to write. I will just say any question? If we give you any two vector fields on a manifold, and I give you gammas of that manifold, will you be able to get the derivative of one vector field with respect to the other? Yes?
The
Now.
little x's or the little q's, they are the degrees of freedom.
Yeah, exactly. Yes.
So the first term will always be that degree of freedom double dotted.
Oh, yeah. Yeah,
Oh.
that's right. Yes. Yes, Joseph?
Can you explain the notation a little bit more? How you go from the term up top for the straight line where you have the gamma sub ij and over k, and then how does that become like a matrix and two vectors?
Yeah, if you have two vectors like maybe V is a vector, right? So it's V1 up to Vn, okay? And W is a vector, W1 up to Wn. And you have a matrix A. So it's matrix Aij, okay? So V as a row, multiplying A as a matrix, multiplying W as a column, this is simply summation, Aij, Vi, Wj. Okay? Yeah, so this is just the definition of the multiplication. Okay? Yeah, I like to lump them. You can go and compute it term by term, use 1, 1, 1, 1, 1, 2, 1, 2, and so on, do all the summations, but this is easy. Any question? Any question about here?